Okay, so I'm Sarah Johnson. I'm the technology librarian here at the Louisville Public Library, and I'd like to welcome you all to tonight's session about the introduction to 3D printing, specifically about our Lulzbot Mini, which is the 3D printer we have here. And it is up here for you to see. If we have time at the end of the presentation, we can turn it on. I can walk you through how it actually works. And then we can see what it's like, because to hear it is one thing. It's completely different from just looking at it. Ours is a little bit noisy, as they sometimes can be. So again, welcome. At the end, I'll have some time for questions. This is a brand new thing for the library. Back in November last year, we started our makerspace. And they're a new thing for libraries in general. So it's all kind of a big experiment. In February, we got our 3D printer. And since then, we have all been learning how to use it, which means I am not a professional at this, but I can get you through the basics, and I can get you started with 3D printing. And this is our first time presenting on it. So if I leave anything out, feel free to raise your hand, or if you have something to contribute. I love having help, and that's kind of the purpose of a makerspace, for everybody to contribute ideas and knowledge, so that we can all learn as we go along. So 3D printing, let's see. And I apologize also, we don't have our little clicker to help me advance slides. So I have to come back here and click through. If you don't have a handout, we have more copies being made. There's a few things in those packets, including a survey on the course, the PowerPoint itself, my contact information, and there might be something else in there. Oh, the user agreement. So if you need any of those, we'll get more copies to you. Don't worry. Some of our objectives for today's course is to introduce 3D printers. What are they? Why should you use them? We're going to talk about the Lulzbot Mini, in particular, some of the important components, what you need to know. We'll talk about filament types, which is what we actually use to create the objects you're printing. We'll go over the software. We use Cura. It actually comes with our 3D printer, so we'll go over how to navigate that and some of the important components. And then we'll actually go through the printing process. Errors that can come up, because that is a possibility. We'll go over our usage policies here, and then also some resources you can access if you want to learn more. And then terminology. And so at the back of your PowerPoint handout, there is a little area of terminology and definitions, because we're going to talk about a few things that you might not have heard of before. So I just wanted to outline those for you. So 3D printers, what are they? You might have heard the terms CAM or CAD. CAM is computer-aided manufacturing device, and that is exactly what a 3D printer is. It is a tool that allows you to print from software on a computer. You can use it to print products or product components out of a variety of materials. So any kind of 3D object, it can be something as simple as a spoon to something as complicated as a drone component. Why use them? A lot of companies today are using them because they're cheap and quick. You can produce many parts very quickly, many complicated parts very quickly, and also very unique products very quickly, which is why a lot of people also use them for beta testing. You can take a model that maybe has already been in existence, and you can tweak it to meet your specific needs. So it's nice that it can be personalized. So why should you use one? You might not be at home making computer parts or automobile components, so why would you need to use one? Well, first off, printers and software, just like regular computers, have become more accessible to the everyday user. Just as computers were once as big as a building, and they're now usable for you in your home, so too are 3D printers. Many people can actually afford them now. The size is more accessible for people. We can actually have one in the library, which wasn't always possible. They're relatively cheap, considering what they do. Our edition here actually cost us less than $1,300. So with that kind of budget and the fact that we can print just about anything, we're getting our money's worth, and I think our patrons are too. And they're functional. You can print, just like I said, absolutely anything. The options are endless. So we have a lot of people also that come in and use them for prototyping. Small business people might have an idea and they want to see what it would look like if they actually created it and printed it. Would it function? What's the size like? So that's one really great use for small business owners or the everyday person who just wants to tinker around and is looking for a very specific part that they can't find in a store. You can make personal modifications. And I don't mean just like adding your initials to things, which you can do with it, but also making specific tweaks that fit your needs. Let's see here. Trying to think of something, maybe you're left-handed and there's a lot of devices out there that just don't fit your left-handed needs. You can actually start to create something that would benefit you. You can make personal tweaks. You can also just use it to learn a new type of hardware and software. As you know, the world is quickly evolving as technology is, and so this is just a way for you to try to stay on top of things, and you can do it here in your library. You can come in and learn about the hardware and software and actually participate in society as it evolves. And then lastly, you can use it just to have fun. We have a lot of kids that come in and actually create Lego pieces or toys. And you can create something fun too. I've got cookie cutters. This is my newest venture here, is learning how to make cookie cutters. And this is a little wiener dog. So you can do fun stuff like that. So our Lulzbot Mini, as I had mentioned, is an easy-to-use desktop printer. It will fit in a very small space, and it's great for beginners. Even if you're not a beginner, though, and you want to try to play with different materials or different fills, we have some advanced steps that you can actually go through into a different screen. Another reason we chose the Lulzbot Mini is that they are locally owned with local customer service. They're actually right out of Loveland. And so we did have to have it serviced about 2 months ago, and we didn't have to pay for those shipping charges. I live up north, so I was able just to deliver the printer back to them, have them work on it, and then pick it up and bring it back to the library when it was ready. So it's really great that they're right there for us. And then, as I had mentioned, they're a reasonable price. $1,200 for the library was really a reasonable cost for us, especially since we got a lot of our funding with help through the Library Foundation. So it's been a really great purchase for us so far. So there are some key parts that you need to know because they're either important or it's a safety concern. And so as you can see, we have the typical power button. Without that, you wouldn't be able to get anywhere. And then we've got a USB port, and that's how the printer actually communicates with the computer. We've got the print bed, which is where the 3D object actually sits and prints on. That gets hot. It needs to be hot in order to keep the filament in place and to keep the object itself at a decent temperature. The print nozzle gets very hot. It gets to about 240 degrees Celsius, over 400 degrees Fahrenheit. So that is something that once you start using it, you do not touch it. Filament, as you can see over here, we've got a roll of filament that's called HIPS. We chose HIPS for a few reasons. Primarily, it's easy to print with, and it's not likely to warp. When you're starting to get used to 3D printing, there's going to be a lot of mistakes, a lot of little hang-ups, and this was actually highly recommended to us by the Lulzbot company. It's a great starter filament. There are some other types, too. They all have their own pros and cons. Most of their pros end up being, for everyday use, about aesthetics. Do you want it to look like wood? Do you need it to be made out of metal? For other people who are actually looking at beta testing, they might want to look at some of the other benefits or drawbacks, such as what is the warp going to be like once it cools? How flexible do you need it to be? There are a lot of really cool new filaments out there that are a rubbery kind of flexible texture. So In the future, we'll probably look at some of these other types of filaments, but not just yet. Do you have a question?
Yeah. Do you have one of those flexible filaments?
So the question was whether or not we have the flexible filament, and at this time, we do not. Once we get more comfortable with the 3D printer and see how other people are starting to use it more, we'll see if that's a good decision for us or not. Okay? One more question? I'm sorry, what was that? You probably won't get a chance to 3D print tonight, but I'll tell you a little bit later how you can set up time to 3D print. Okay? All right, so we have software, and as you'll see on your slide, or your handouts, I've got some screenshots there. Cura actually came with the Lulzbot. It is a completely free open source software, which means anybody can download it, and anybody that knows how to edit code can actually go in and improve upon it and share their improvements with the world for free. So it could constantly be evolving. We get new updates that we have to install every once in a while, but the fact that it's free means that you can work on it at home or anywhere. The Cura software will also prepare your file and convert it into the correct code so that it can actually be printed. So your computer is where you have your file, but it needs to speak the language of the 3D printer, and that's what this software will help you do. It will help convert that language for you. The software also gives you the ability to actually control the 3D printer, so you can start it, you can pause it, you can adjust the temperature of the nozzle or of the print bed. As mentioned before, it's easy for first-time users. We have a beginner mode that we highly recommend everybody stay in. But we also have an advanced mode that some more experienced users can delve into. Few things that we'll also get to a little bit later. The file formats for Cura and the 3D printer must be in STL. Now I know most people haven't really heard of STL, but this is just the file format it needs to be in. Most 3D modeling software has you save it in that format or export it in that format. So you don't actually have to worry about focusing on that so much, especially when you're just getting into printing. If you are going to be creating your own models, it needs to be in millimeters. That's what our software and the printer operate in. We've had people come in inches, and then we have to try to find a way to convert it down to millimeters. And it can only be as large as the print bed, whatever you're going to print. This isn't on your handouts because somebody actually brought it to my attention about 10 minutes before everybody started showing up, so I just popped it in there. The print bed is approximately 6 by 6, and then also 6 inches high. It's about as big as you can get. So something to keep in mind. You can't print anything gigantic here. So here are some of the important areas you need to know about in the Cura software. These are the only things you're really going to have to concern yourself with when you're first getting started. So we've got on the left-hand side here, as you can see, that beginner mode. That's the ease of use. We've also got it set to HIPS, which is that type of filament that we use. And we've got it, so far, set to a standard print. So the settings, there's a few other things you'll probably end up checking when you do end up printing, and that's going to be to print a support structure and to print a brim. I'll get into those a little more. I actually have some examples I'll hand out too, so you can see what I mean by brim and support structure. So we've got the image here in the center shows the print bed and the object we're going to print, and it shows that object as it will be when it prints. So it will be in that exact position on the print bed and will look exactly like that when it's done, though a different shade of green. We've got also the print time, which is just an estimate. The heat up and cool down process takes a little longer. So this little snail here will take about 1 hour and 14 minutes to print. And then we've got a control button, and that's how you'll actually start the print and initiate the printer itself. Any questions on this screen? Okay. So as I mentioned about the settings, this is how you'll prepare your object for printing. A lot of the times what we have going on right now is people that are pulling models off of the internet that have already been created. So they might just be making a few tweaks to size. But again, you'll just want to stay in this beginner mode and keep everything as it is, and then check print support structure and print a brim. Those are kind of just a safety feature that help your print come out the best that it possibly can. I'll show you here. I've got an example, and I think I go into it a bit more. So when you edit your object for size, what you'll do is you'll click on the actual object you're printing. You'll get a little white outline around it, and 3 boxes that show up at the bottom of the screen. Those boxes allow you to resize, rotate, or create a mirror image of your object. So it's really easy to make simple adjustments. And the really cool thing about the scale adjustment is that it stays in proportion. So you really only need to change the X field or the Y plane, and the rest will adjust accordingly so that it prints appropriately. If we changed the X field and made it smaller and didn't change anything else, that snail would probably not look quite like a snail. It would be misshapen and warped. So keeping scale is pretty important, unless you want something kind of goofy. Oh, go back if I can. Okay, so if your object happens to be gray when you're looking at the print bed, that means it's either too big or it's not completely on the print bed. That's all. So you might need to either click on it and readjust where it is on the print bed, or you'll need to scale it down a bit. So when you're actually ready to print, you'll click that control button that we saw at the top of the screen. That will start the printer, get it warmed up to the appropriate temperature, and initiate the print job. So let me actually stop for a second, because maybe I don't have another slide on the support structure. But I've got a few things to pass around. This first one here can be a little pen holder, and it only has a brim. The brim will help your object adhere to the print bed as it prints, so that it doesn't slide around as the nozzle moves around it. So that's why we always use a brim. It's just a little extra safety. Support structures will actually be printed wherever there's an overhang. So right here I've got like a little fennec fox. And because it's a 4-legged creature with overhang or negative space, you need to have a support structure so that it can actually print. Otherwise, you're just printing into thin air and it won't look like anything. So once your print job is actually done, you can easily break off the support structure. It just picks away. We have a few tiny little tools that you can use too, just to flick them away. Same thing with the brim. Once you're done and you remove it from the print bed, you can gently peel that brim away. Any questions on those two things? Okay. So once you do click print and you've got your brim selected and your support structure, which the printer will do completely on its own. You don't need to worry about placing support structures. It just knows how to do it. The printer is going to go through a series of steps that sound a little scary when you're just watching the printer because it makes a lot of weird noises. It needs to heat up to a temperature where it can clean itself. The nozzle can actually clean off any old dried filament. So it's going to heat up a bit, and then it's going to do some stuff at the back of the print bed and clean itself. And then it's also going to level and find its place on the print bed. So the nozzle is going to move and touch all 4 corners and find its place. Once those few things are done, it's going to continue heating up to the 240 degrees Celsius. And once it hits that point, it's going to start to print. It usually prints a skirt first, which is just an outline of the object you're going to print. And then it will start to do that brim, and then the object. So it takes a little bit of time to actually get started. So again, when it estimates an hour, you're looking at more like an hour and 20 minutes, including the warm-up and the cool-down period. Another really cool thing, though, is that you can actually watch on the control box and see as it heats. It shows a graph showing the temperature rising, and then it also mentions it across the top in the temperature field. This control box you won't have to deal with when you're just getting started at all. You may never deal with it, but it does give you some extra options, such as moving the nozzle around to a specific location or adjusting the temperature to a specific temperature. So printing errors. We cannot guarantee that your print will always be successful. So there's always a chance you'll come in and be kind of disappointed for the day. We hate when it happens, but it does. There's quite a few errors that are possible, and there's a couple reasons why they might occur. The first thing is that sometimes models just are not designed well. Although they look cool on websites where you pull them off from, they might not actually have all the structural elements that are necessary. Sometimes it also just doesn't work with that type of filament. You might pull something off that is supposed to work with a wood kind of filament, and we don't have that, so it's not going to come out the way you want it to. Sometimes the communication is just off between the computer and the printer. Just as you get printing errors or you can't figure out why your printer at home isn't working, same thing with this. It just takes a little bit of troubleshooting, which I end up doing, so you don't have to worry about that either. And then again, just as your computer at home freezes, sometimes the 3D printer does that too. It gets confused, It's not as smart as we like to think it is. It does amazing things, but it's not flawless. So I've got a few pictures here of some screw-ups. One of the issues that comes up a lot is that the print isn't sticking to the print bed. And the brim will solve that most of the time. Sometimes it just doesn't, though. I do maintenance on the print bed every once in a while, so it might just be that I need to go ahead and resand and clean the bed. Sometimes also the filament doesn't stick to itself. Maybe the fan isn't working the way it's supposed to, and you get something that looks like spaghetti. Just makes a mess. And then again, if you didn't click on having a support structure and your print needs a support structure, it's also going to look like a mess because that filament's just going to go wherever. It's not going to be in the right form. Did everybody get to see all the prints? The structure? No? Okay. So, waiting for your print to finish, especially when it's your first one, can be terrible. You just want it to be done, you want to grab it off the print bed, and you get really impatient. So even when you think it might be done and the nozzle has lifted up and it's done printing, you still need to wait a little bit. The printer is going to cool down and cool your object down, and you need to wait until that process is done. And the good news is the printer will let you know when it's completely done. The print bed itself will move itself to the front of the printer as if to present your object to you. So you'll know when it's completely ready to go. And then here at the library for safety issues, we do ask you to let a staff member know at the reference desk when your print is done. We have this little tool that's basically a special knife that we don't want everybody handling, and that's how we get your print off the print bed. Some of the prints are really easy to lift off by hand, but some of them take a little bit of chipping at. So that's why we ask you to let us know. We'd rather be the ones that get hurt than a patron. Removing support structure. So I did get into this a little more. Here's some more examples of the support structure. You can carefully remove it by hand or with special tools. And here's just an example of what that can actually do for you. As you can see with this image on the left, the white filament is the support structure, and without that there, those gray pieces wouldn't have anywhere to go. So then once you chip away the support structure and get the object on the right, that's your final product. With some printers. With our printer, it is not. Our printer just uses the one filament, as you had seen on that Fox, and does a print structure with that. Some really high-tech ones that have multiple nozzles will use different filaments. This is actually a really special filament in this image that can be degraded in water or special chemicals. So you can actually drop your object with some filaments into a solution that dissolves it. So we're not there yet at the library, though. Yeah, what's your question? Do we have that filament yet? Nope, unfortunately we don't. I'm hoping we will in a few years, though, because that's really cool.
You're saying some support filaments dissolve in water?
Yes, some support filaments do dissolve. Okay, so here's our usage policy. This is also on the agreement that I had set out on the table. We do ask that everybody signs that agreement and reads through it, and that's just so that we know, you know how hot it gets, you know that you need to get assistance at certain times. So each individual is allowed to print for a maximum of 2 hours each week, and that is completely free. We are not asking you to pay anything for the filament or for the time. Again, you sign our user agreement. You have to have a staff member present to start the print, at least for the first time. If you're a regular and we get to know you and we know that you know what you're doing, we'll give you a little more free rein, but we just want to make sure everybody can get it started appropriately. And again, you must have a staff member remove your completed job simply for safety reasons. Although we do prefer that you reserve a time to print, if the printer's not in use, and if we have a staff member available to get you started and finished, we'll let you use it just about any time. But again, we cannot guarantee that just because you come in and want to print, that we'll be able to help you that day. So I have on the ends of these packets here my contact information, and that's the preferred way to make an appointment. Honestly, I'm not great about voicemail. It's one of the last things I check in the day. But if you email me, I will respond to you that same day or the next morning and let you know what kind of time or day works well. And then again, for our usage, do not leave the beginner mode in Cura unless you do check with one of us first and we do know that you know what you're doing. We've had a few people move into that mode and then can't figure out why their print job isn't working. Move it back into beginner mode and it prints just fine. So unless you really know what you're doing, you don't need to leave beginner mode. So we've got some resources here. We've got 2 websites for pre-designed models. It's Thingiverse and Tinkercad. Both are completely free to use, and you can actually download free models. And there are a ton of them. I think just about everything we've printed have come from one of these sites. So you can find almost anything you need, including drone parts. We have a regular that comes in and prints drone parts, and he gets them all from these 2 websites. We do have some options for learning to create models. 2 times a month on Sundays, we have a high school student who's absolutely brilliant, and he will help you learn how to create 3D models using a software called Onshape. And Onshape is a cloud-based software, which means you can log into it from any computer, just like you would your email. So it's a great way to get started and to work on your project from various places or locations. We also have Blender and SketchUp on our Macs up in the makerspace. Those are 2 other modeling softwares. They're not as easy to use, so if you don't really know what you're doing, it's not a great way to get started. But Tinkercad and Thingiverse also have some introductory courses, so you can get started with models. But again, Sundays, if you come to our Open 3D Modeling Lab, our student will help you get started. He'll show you how to build a sphere, how to build an octagon in a 3D model, and then you can reserve a time to actually come and print your own model. Onshape. He's usually here from 1 to 3. And I do have some handouts upstairs. It didn't make it onto the September calendar for some reason, but he will be here on the 11th. I know that date for sure, at 1 o'clock. So again, here's our terminology that we pretty much went over everything. Fill. Fill is something different also that you really won't have to deal with just yet when you're getting started, and that's how solid your object is going to be. How many layers of filament are going to be inside. Right now, most of the things that you print that are solid are actually kind of a honeycomb or grid shape inside, so it's not completely solid. But if you need something that's going to be more structurally sturdy, you can actually change that fill percentage to 100%. Or if you need something to be completely hollow, you can do that too by making it 0%. And I think that's it. Any questions on those? Yes?
You mentioned that, excuse me, the library has used it. And could you give us some examples of how you have used it?
Sure. So the question was, how has the library used the 3D printer? We have made cookie cutters, as I had passed around. We're actually going to be giving those out at the rec center. So we use them for ourselves to make prizes. We've made a funnel that we actually use in the maker space. We needed some way to capture all of our tiny little beads from jewelry classes. And we found that using this little funnel we made was a great way to do that. Yeah, so we don't use it so much as other people from outside the library. We use it for our own benefit every once in a while or to test new ideas out. But mostly we get people coming in to create Lego pieces, drone pieces. We had somebody create a camera lens cover. So really the options are kind of endless, but we like to do fun little stuff for the library. Yes, I have some other questions.
Can you like make the filament change color without it like being a different filament?
Can you make the filament change color without it being a separate filament? You cannot. There might be a filament out there that does that has multiple colors, but ours doesn't. And that's actually a really good question. So right now we have this green filament on here. That is one thing that we don't just change at request. If it's on the green filament, that's what you're going to have to work with. Might not have been one of our best decisions getting green filament, but as we've learned that we'll probably get black or clear in the future. I think it's just more friendly for the average person. You can actually paint your print job though too. So if you really want it to be black or gray, you can print that green filament or paint it rather. One more question over here.
If you make it completely hollow, like you need support structure?
Yes, so the question was if you make it completely hollow, will you need support structures? Yes, absolutely, and so that's one of the cool things too. Only though, actually my brain is working here, so if you're going to have one open side to your object, as if you're creating a hollow box or a hollow bowl, you will not need support structures. But if you want it to be completely hollow and have each side enclosed, then you do. My brain is still working here. You will need support structures either way. Thank you. Interesting.
But if it's completely hollow, then you have to distribute it.
No, they'll be really fine, thin things. And honestly, you kind of stumped me a bit, so we'll have to do a little work on that. Maybe you can come in and try printing something like that, and we'll see what happens. Okay. Yes?
You said email is the best way to get you. What is the email address?
Oh, the email address should be on the back of your packet. If it's not on that little slip, I have some extra ones. Okay, you didn't get one. I'll get you one before you leave. If you don't have one, just let me know. We have more over here. Okay. Oh, and then here on the slide, this one also didn't make it into your packets because it was another last-minute thought, but there's my contact information again. And we have time to actually start a print job. So what I'm going to do, it's going to take me a minute here. I'm going to hook up the laptop that we use so that you can actually see it on the screen here. Hopefully this will work. And then we'll get a print job going. And you can actually hear and see what it's like. Thanks. Okay, so that is not going to work. We need a different HDMI adapter. This is a little bit older of a Lenovo ThinkPad, but we'll still make this work somehow. You can all either gather closer, or I'll try to just show it on a table over here. Yeah, we'll just move it to this other outlet. Sure. I honestly wasn't sure we'd have time for this, so it was kind of a, it won't work deal. I'm actually going to plug it in here so we have a little more space. So I had a question, how many people are trained to use this? And the answer is there are about 3 of us who can use it really well, and then the rest of the staff has a pretty good idea of how to use it. We also have a quick start guide that our staff can look at, so that if they can't quite remember how to do everything, there's some prompts that they can jog their memory.
Which are the parts that get hot, which I assume you then should not be touching?
Right, so the hot parts are the print bed itself, this whole flat section, and then the nozzle up here, okay? Oh, yes, so that's another interesting question. Is the green parts of the printer, have they been 3D printed? Yes, a lot of the parts on the 3D printer have been 3D printed. So we actually have the ability to print our own replacement parts, which is cool. Okay, so I would like to show you how to actually go on to Thingiverse or Tinkercad. But since we are recording this and there's not many people here, I'm just going to go ahead and start a print job for you. So, yep, we're going to turn on the 3D printer. Right now, it's hooked up to our laptop where the software is located. It's plugged in, and it's ready to go. Okay, so I'm choosing to print that Fennec Fox again that has the support structures. Right now it's saying it's going to be 1 hour and 32 minutes, so I'm going to resize that as I had shown you in the PowerPoint, so it's a little smaller and a little more manageable. And it's amazing how small some things will print. They're barely there sometimes. Okay, so I've got it set to 40 minutes, and I'm going to go ahead and click the print button from that control menu, and you'll start to hear it do things, so I'm going to be quiet. Right now, as I had mentioned earlier, it's going to start to heat up so that it can clean itself and so that it can find itself on that print bed. The filament is actually about, well, for the hips, for a roll, I think it was about $45, so also very reasonable, and we've been using this same roll since February. They last a really long time. So I can see from the control panel that it's currently at 83 degrees Celsius, and it's climbing. So at the back of the 3D printer here, where it's going to clean itself, there's a little pad that can be changed out, and that's where it's going to start. It's going to drop itself down, and it knows exactly where it's at. So the question was if you can bring in different filaments. This is not the only compatible filament, but it's the only filament we're going to be using right now. And because of the process for changing out filament, we're not willing to change it out for single print jobs at this time. You have to heat it up a bit, and then there's a little bit of a process you have to go through to actually change the filament and get it feeded through again. So now it's going to clean itself. And now it's finding the location on the print bed and making sure everything's level. It's touching all 4 corners. And then once it's done with this part, it's going to sit there and heat up until it's at that 240 degrees Celsius. How long will the part take? The part will take about 40 minutes, it says. Yep, so we won't be able to see it finish itself tonight.
And how long does it usually take to heat?
It takes,
To the 240.
to heat to the 240, about under 10 minutes. Some days it seems to go quicker than others. Yeah, we're at almost 190 now. And this one's actually going to be really interesting because, as I had mentioned, the makerspace is all about learning, which means messing up sometimes. And I just noticed that this one does not have a support structure or a brim. So you'll probably see it make a mess because it won't know how to print the head since it has an overhang. And that's okay because it's really great to learn from. The first time we experienced something like this, we thought we broke it. And the truth is, you really can't break it. If I haven't broken it by now, I don't think anybody can. But it's interesting. If for some reason your print job does look crazy or it's not doing what it's supposed to do, though, it's really easy to either cancel the job from the computer or just shut the machine off. It really won't harm it. So we must be at about 240. And it's going to start the print. So the funny thing about the Lulzbot, when they made it, they had created it so that each location of the nozzle kind of played a different note. So it's a little annoying in that it's very noisy, but it's also kind of cool for kids or for first-time users. I think it was actually made in Loveland. Yeah, they do all the repairs there, too.
So the 3D printer that's down at the main library, what do we call it, in Boulder? Does it make objects bigger than this?
So the question was whether or not the 3D printer in Boulder makes larger objects than this one, and I don't know. I haven't seen theirs. If it's got a bigger print bed, then it probably does. I think it all revolves around that size of the print bed.
And I was told that if you go up to Loveland, it's a factory up there where they're making printers, and the laser printer can make another laser printer.
Right, yes. The factory in Loveland, where we took this to get repaired, they have everything up there. And I think you can take a tour, too, if you want to go up there and see what they have going on. They have a lot of stuff going on at that location. It's actually called Aleph Studios. So you won't find it under Lulzbot. They use a different name. Aleph, A-L-E-P-H. Yeah. Is it making a mess already?
It doesn't have the brim. Everything's sliding off.
Yes. So we've got a great example of an error print job. I would love to turn some more lights on. Would you mind? I will stop it, but this is a great opportunity to see a mess and to see just what is possible in terms of errors. So that way, if you come in and you print something and it does this, you don't have to worry about it. There. So then let me just angle this a bit so we can.
Completely making a nice mess. Look at that
Sweet.
beautiful mess.
What should it have looked like?
So it should have looked like the fox that I passed around with the support structure. Yes, so it should have looked like this, and instead it looks nothing like this. All right. So I'll go ahead and stop it now. And this was a great opportunity, actually.
Now, whose responsibility is it to put in the base? Should the computer have known that, or is it
It was a user error this time, yeah. I should have clicked support structure in Brim, and it just, in the moment,
So it's
I
another
lost
command,
it.
it's a completely different command, evidently?
It is, on your handout, there is a section for settings, and I marked that you should always check support structure in Brim, which I definitely didn't do, for this very reason. So if you want to come up and look at it, you can, and then once it's done and I shut it off and it writes itself, I'll pull that off the print bed. And it actually ends up making a mess on the nozzle, so I might have to clean the nozzle a bit, but that's part of my job.
Why don't you just make it clean itself?
Because it's a little bit too much of a mess. Once the filament gets onto the top or the more upper parts of the nozzle, that little pad at the back won't do it. So were there any other questions before we call it a night?
Yes, I had one question.
Okay, one more question.
It, on one page, let me get it, something about if it's in millimeters, but then you said something about the print bed will be 6 by 6 by 6.
Right, so the
That's
print,
inches, but not
right,
millimeters.
yeah, so the print bed is 6 by 6 by 6 inches, but your print job itself needs to be in millimeters. When you actually go into the scaling, those numbers are going to be in millimeters. So this fox here is approximately 25 millimeters along its x-axis. So from one end to the other while it's standing. And it's a different size than this one. I don't know what I printed this one at. Yep.
Thank you so much.
You're welcome. So feel free to reach out to me if you're interested in experimenting with it. We'll always find time to accommodate. Okay? And also, I did have, for most of your handouts, a little survey. If you wouldn't mind filling that out, we would love to know what else you'd like to see in the makerspace or what we can do differently. Again, since it's a new space, we're looking to improve, so be honest. Tell us what you think. And if you need an extra part or an extra handout or sheet, let me know. I'll grab it for you, and I'll grab my contact information for the few of you that needed it. Okay, but thank you for coming tonight. This is great. I hope that we get a little more usage. It was really busy over the summer, but now that school started up again, our usage has dropped off. But I'd love to have more adults coming in, too. If you need anything, if you need a spoon, come print it. Seriously.
What's the minimum resolution?
It depends. So even though it's in millimeters, there are settings to do more detailed prints, and I honestly don't know those numbers. That's a little even beyond my scope. But we can learn. We'll figure it out. We can do some researching. If you have a part, do you have to be there the whole time? No. No, you do not. That's a good question. We've had people come in and try to print something in an hour window, and something got weird with it, or they had an emergency come up. We'll finish the print job for you, and then we'll hold it at the reference desk, and you can come pick it up another day. All right. Thanks, guys.
This is located upstairs?
Yes, the makerspace is up on the second floor.